Hi, I am Rashani DeBell, and you are learning algebra.
Hi everyone. In part 2 of solving linear systems using combinations, we're going to learn how to use multiplication and rearrange our equations so that the like terms line up in order to solve the system using combinations. So let's go ahead and get started. In this equation, we are asked to solve the linear system 3x minus 5y equals 15 and 2x plus 4y equals negative 1. Again, none of the variables have a coefficient of positive or negative 1, so I have to use the idea of combinations in order to solve this system. I can get the coefficients of x to be the opposite of each other by multiplying this first equation, 3x minus 5y equals 15, by 2, and the second equation, 2x plus 4y equals negative 1, by negative 3. So let's go ahead and do that. This first equation, 3x minus 5y equals 15, I'm going to take this entire equation and multiply this by 2, which transforms the equation to 6x minus 10y equals 30. I'm going to do a similar process with my second equation. So I now have 2x plus 4y equals negative 1. And I'm going to multiply that by negative 3, which gives me negative 6x minus 12y equals positive 3. By multiplying these two equations, I've managed to get a positive 6x and a negative 6x, which now allows me to add the two equations, transformed equations. 6x plus 6x is 0. Negative 10y plus a negative 12y is negative 22y equals 33. 30 plus 3 is 33. And I can solve for y by dividing every term by negative 22 and simplifying. Y is equal to 33 divided by negative 22 is negative 1.5. I'm going to take my value for y equals negative 1.5 and substitute it in for x in the second equation and solve for x. So we'll do 2 times x plus 4 times negative 1.5 equals negative 1. 4 times negative 1.5 is negative 6. Isolate 2x by adding 6 on both sides, and I get that 2x is equal to a positive 5. Isolate your x by dividing both sides by 2, and you get x is equal to 5 halves, which is approximately 2.5. So my values for x is 2.5, and my value for y is negative 1.5, and I am going to check my equations to make sure that this is the solution to the system. So taking the first equation, I've got 3 times 2.5 minus 5 times negative 1.5. Does that equal 15? 3 times 2.5 is 7.5. Negative 5 times negative 1.5 is a positive 7.5, and when you add that, you do get 15, which is equal to 15. So it works in the first equation. Let's check the second. We've got 2 times 2.5 plus 4 times negative 1.5. Does that give me negative 1? 2 times 2.5 is 5. Positive 4 times negative 1.5 is negative 6. There are different signs. I'm going to subtract and keep the sign of the bigger number, which gives me negative 1. That is equal to negative 1, and therefore our solution to this system is 2.5 and negative 1.5. In this example, we are asked to solve the linear system 3y is equal to negative 6 minus 4x and 7x plus 3y equals negative 15. As you can see, our like terms are not arranged in columns. So our first step over here is to write this equation in standard form so that it looks like this equation over here, and that way we can line up our like terms. In order to do that, I am going to add 4x on both sides. In doing so, I now have 4x plus 3y equals negative 6. And my second equation over here, 7x plus 3y equals negative 15. Once the like terms are lined up, you can see that I have a positive 3y and a positive 3y over here. So in order to be able to combine these two and eliminate one of the variables, I need to have one of these 3y's become a negative 3y. To do that, I can get the coefficient of y to be the opposite by multiplying the second equation by negative 1. When I do that, first have 4x plus 3y equals negative 6, and I have my second equation, which is 7x plus 3y equals negative 15, and I'm going to multiply this entire equation by negative 1, which now transforms my equation to negative 7x minus 3y equals positive 15. Still have the original equation, first equation, since I haven't done anything to that. That is 4x plus 3y equals negative 6. Now that I have a positive and a negative 3, I can add these two equations together. 4x minus 7x gives me a negative 3x. Positive 3y minus 3y is 0, and negative 6 plus 15 is 9. Solve for x by dividing every term by negative 3, and I get that x is equal to negative 3. I'm going to substitute x equals negative 3 for x in the second equation and solve for y. So I've got 7 times negative 3 plus 3y equals negative 15. 7 times negative 3 is negative 21 plus 3y equals negative 15. Add 21 on both sides. I get 3y is equal to 6. Isolate y by dividing every term by 3, and I get y is equal to 2. I am now going to check my work and make sure that my solution of x equals negative 3 and y equals 2 works in my system. Taking our first equation, 3 times 2, does that equal negative 6 minus 4 times negative 3? 3 times 2 is 6. Got negative 6. Negative 4 times negative 3 is a positive 12. Negative 6 plus 12, they're different signs, so I subtract and keep the sign of the bigger number, which gives me 6. Yes, that's equal to 6. So it works in the first equation. Let's check the second equation. I've got 7 times negative 3 plus 3 times 2. Does that equal negative 15? 7 times negative 3 is negative 21. Positive 3 times 2 is positive 6. Negative 21 plus 6, they're different signs, so subtract, keep the sign of the bigger number. I get negative 15 is equal to negative 15. It works in the second one as well. Therefore, my solution to this system of equations is negative 3 and 2.
And that is how we solve a system of equations using combinations. Thanks for watching.